The dovecote smells of grain dust and warm feathers. Inside, 15 breeds move along the perches. Each one is a separate argument made in bone and quill. The pouter inflates its crop until the body disappears. The fantail spreads 36 tail feathers in a trembling wheel. The tumbler climbs high above the rooftop, then folds and falls. The carrier stretches a beak long enough to seem designed for another world. They are not from another world. Every one of them descends from a single bird. The rock dove, Columba livia, nests in sea cliffs. It is a modest animal, blue-grey, white-rumped, unremarkable. From that one ancestor, breeders have drawn these extreme forms. They did it over decades, not centuries. They did it without any understanding of why it worked. The question of where species come from is very old. For most of recorded natural history, the answer seemed obvious. Each species had been made separately, fixed at its origin, unchanging. The majority of naturalists, until quite recently, held this position. Many defended it with skill, but a minority had long suspected otherwise. Buffon wrote carefully, inconsistently, and never named the mechanism. His views shifted between publications. He observed resemblances, but drew back from the consequence. Lamarck was the first to make the argument plainly and in public. In 1801, he stated that all species, including man, descend from other species. He expanded this in his Philosophie zoologique of 1809. He returned to it in 1815 in his Histoire naturelle des animaux sans vertèbres. His service was real. He insisted that living change obeyed laws, not miracles. But he placed the mechanism in the wrong place. He believed the giraffe's neck grew long because the giraffe reached upward. He believed effort, repeated across generations, became inheritance. That mechanism does not hold. Others followed with partial views. Geoffroy Saint-Hilaire thought forms were variations on a single underlying type. He was cautious about whether living species were still changing. His son recorded his final position. A problem to reserve entirely for the future. Patrick Matthew came close in 1831. In an appendix to a book about naval timber, he sketched the essential idea. Almost no one read it there. He did not follow through. The anonymous author of Vestiges of Creation in 1844 reached a wide public. The writing was energetic, the argument incomplete. It prepared the ground without building anything permanent. Wallace studied the fauna of the Malay archipelago and arrived at the same conclusion. In 1858, his paper was read alongside another naturalist's at the Linnean Society. The two men had reached the same place by different routes. The naturalist, who returned from 5 years aboard HMS Beagle in 1836, had noticed something. The distribution of creatures in South America did not fit a world of fixed species. The geological succession of forms in the same region did not fit it either. He began collecting facts. After 5 years, he allowed himself some general conclusions. He wrote a brief sketch in 1842. He expanded it in 1844. For 15 years after that, he kept gathering, kept checking, kept revising. The starting point was not a remote island or a fossil cliff. It was the barnyard. Domestic animals vary. That observation seems trivial until its implications are followed. A duck kept in a farmyard flies less and walks more than its wild ancestor. Its wing bones, when weighed, are lighter. Its leg bones are heavier. The change tracks the change in behavior across generations. Cows and goats in regions where they are regularly milked develop larger udders. The trait is enhanced where it is exercised. White cats with blue eyes are, as a rule, deaf. A more recent observer found this holds mainly for the males. Virginia farmers keep only black pigs. The reason is practical. A plant called paintroot kills pigs of other colors. It colors the bones pink and causes the hooves to fall away. Only the black animals survive long enough to breed. The farmers had not designed this. They had simply kept the ones that lived. This is the mechanism without a name. Useful variation is preserved. The rest is not. Wheat is among the oldest cultivated plants in the world. It has been grown for millennia. It is still producing new varieties. This is not a trivial point. If a species under human care has not reached its limit of change after thousands of years, then no limit has been found. The pigeon makes this case more dramatically than any other domesticated creature. Darwin kept 15 breeds himself. He wrote to breeders in India and Persia. He joined 2 pigeon clubs in London. He examined the skeletons. The English carrier pigeon has a beak extended to improbable length. The skin around its eyes and nostrils thickens into warty growths. The short-faced tumbler has a beak like a finch. It rises in flocks, reaches a great height, and falls backward through the air. The Roman pigeon is massive, with enormous feet. Some strains carry very long necks. Others carry wings and tails extended far beyond the body. The pouter's esophagus has swollen into the crop that fills the chest. The Jacobin has a hood of reversed feathers covering the head entirely. The fantail carries 30 sometimes 40 tail feathers. In the healthiest specimens, the head touches the upright tail. The oil gland at the base of the tail has disappeared in this breed entirely. A trained ornithologist, shown 20 of these birds as wild specimens, would name them as 20 separate species. Some he would place in entirely different genera, yet every one of them, crossed with any other, produces fertile offspring. And when the crosses mix further, the blue-grey plumage of the rock dove reappears. The white rump returns. The dark wing bars come back. This is not coincidence. This is the signal of common descent. All of it traces back to Columba livia. The evidence from skeleton, from plumage, from crossbreeding, from the reappearance of ancestral markings, leaves no other conclusion. Around 1600, the Emperor Akbar kept 20,000 pigeons in his household. Monarchs of Iran and Turan sent one another rare specimens as gifts. The court historian recorded that His Majesty had improved the breeds through crossing, something that had not been done before. The Dutch bred pigeons with the same intensity the Romans had. Ancient Chinese encyclopedias described selection principles. Pliny recorded that enormous sums were paid for birds of good pedigree. None of these breeders understood what they were doing in any formal sense. They were preserving variation that pleased them. They were discarding the rest. Over enough generations, small preferences compound. No individual choice seems significant. The accumulation becomes enormous. This is what the naturalist called unconscious selection. The breeder does not aim to create a new form. The breeder only keeps the best. But the best, breeding the best across a century, becomes something the original breeder could not have predicted. The pointing dog was not designed. It was accumulated. The racehorse was not blueprinted. It was incrementally preferred. No breeder woke one morning with the intention of making a pouter pigeon. Someone noticed a bird with a slightly larger crop. They found it interesting. They kept it. They bred from it. Generations later, the form had traveled far beyond that first small preference. The same engine is not confined to dovecotes or cattle pens. It has been operating in every habitat on Earth. It has been operating for longer than any human institution has existed. It has no breeder to direct it. But it has something the breeder does not: unlimited time and pressure from every direction. Every individual in nature differs slightly from every other. This is not metaphor. It is observation. No two pigeons in any flock are identical in all particulars. No two oak trees in any wood are identical. The variation is always present. The question is which variations are preserved. In nature, Nothing is preserving them for human convenience. Something else is doing the work. What that something is, and what it costs every living thing, opens with the world beyond the fence. No two plants in this meadow are identical. The difference may be invisible to a passing eye. One stem is fractionally thicker than the next. One root runs a degree deeper into clay. One leaf catches more light along its upper edge. These are not flaws. They are the raw material of everything. Among the flowering plants of Great Britain alone, 200 or 300 forms exist. Naturalists argue endlessly over whether to call them species or varieties. The argument reveals the truth. The line between the two is not fixed. It is a moving threshold, and things are always crossing it. Species that dominate their range show the most variation. The common ones, the widespread ones, the ones that fill a region. They generate the most distinct forms. This is not coincidence. Where a group has already found ways to succeed, it keeps finding more. Each spring, a single annual plant casts its seeds into the ground. Suppose it produces only two seeds, 2 plants, 4 seeds the following year. Linnaeus calculated what follows. After 20 years, that one plant becomes 1,000,000. The elephant breeds more slowly than any other creature on land. It does not reproduce until its 30th year. It continues until its 90th. In that time, it produces 6 young. From a single pair, across 5 centuries, the descendants would number nearly 19 million. The world has never held 19 million elephants descended from one pair. It never will. Something prevents it. Something prevents the 1,000,000 plants too. And the fulmar, which lays only 1 egg per year, is still the most numerous bird on earth. The arithmetic of unchecked reproduction collides with a world that cannot hold its product. Every habitat is already occupied. Every food source is already contested. Every patch of soil has something growing in it. A plant at the edge of a desert does not fight drought the way 2 dogs fight over a carcass. But its existence depends on moisture. When moisture fails, the plant fails. This is still a struggle, even without combat. A mistletoe on an apple branch does not wrestle the tree. It simply takes from it. If too many mistletoes crowd onto one branch, the branch wilts and dies. The mistletoe has destroyed the thing it depended on. Several mistletoe seedlings growing close together on the same bough are competing. Birds carry mistletoe seeds. The plant depends on birds. To attract birds, it must compete with every other fruit-bearing plant in the region. Its survival is entangled with creatures and pressures it never touches. This is the web It extends in every direction, through species that share no obvious connection. In Staffordshire, fencing off a patch of heathland and planting Scots pines changed everything. 12 new plant species appeared inside the enclosure. 6 new species of insectivorous birds followed. The cattle had been grazing the open heath. The cattle were responsible for the absence of pines. The pines were responsible for the absence of those birds. Pull one thread, and the pattern shifts across the entire cloth. In Paraguay, cattle and horses did not run wild, though they flourished north and south. A fly was responsible. It laid its eggs in the navels of newborn animals. That fly was kept in check by parasitic insects. Those insects were eaten by insectivorous birds. The birds were controlled by mice. The mice were hunted by cats. The abundance of cats near villages kept the mice down, which kept the birds up, which kept the parasitic insects up, which kept the fly in check, which allowed cattle to survive in Paraguay. A region's cattle population traces back through this chain to the abundance of cats. Climate appears to act directly. A hard winter kills birds. One winter reduced the bird population of a single estate by 4/5. Among humans, an epidemic killing 5 in 100 is considered catastrophic. 4 in 5 is almost beyond comprehension. But climate rarely works alone. A cold spring does not simply kill. It tilts the balance between competitors. A plant that barely holds its ground in warmth cannot hold it at all when weakened. Its rivals expand into the space it loses. The cold did not defeat it. The cold let others defeat it. Traveling from south to north, species thin out and vanish. The cause looks like climate, but the real cause is the cascading advantage it grants to every neighbor. Remove a species' competitors, and it survives the cold. Keep the competitors, and the cold only needs to tip one small scale. Some species can hold their numbers only when they occur in large groups. A rare plant becomes common only in the one valley where its conditions are met. Isolated individuals cannot survive what a community can. Cross-pollination depends on proximity. Defense against herbivores depends on abundance. Safety comes in numbers, and numbers require that enough already exist. The struggle is most violent between the most similar. 2 canines starving in the same territory will fight, but a canine and a hawk do not compete the same way. It is the species that eat the same food, nest in the same places, breed at the same season. These are the ones who push hardest against each other. A swallow spreads across certain parts of the country. A second species of swallow declines. A song thrush extends its range in parts of Scotland. The missel thrush contracts. One kind of rat replaces another across whole continents. In Russia, a small Asiatic cockroach spread. The larger native species vanished wherever the newcomer arrived. Introduced honeybees in Australia quickly displaced the small, stingless native bee. The native bee had lived there for longer than any record exists. The honeybee required weeks to establish itself. These are not events separated by slow geological time. They happen within decades, sometimes within years. The pressure is continuous. Within this pressure, the smallest advantage compounds. A wolf hunting deer grows fastest if it is fastest. A slower wolf leaves fewer descendants. Those descendants are, on average, slower than the descendants of the swift wolf. The swiftest wolf does not know what it is doing. It is simply surviving. But across generations, the wolves that survive are the wolves that run faster. No single individual changes. Populations shift. The change is invisible in any one generation. Across hundreds, it becomes the difference between a greyhound and a mastiff. In the Catskill Mountains of New York, two varieties of wolf already exist side by side. One is lean and long-legged and hunts deer. The other is heavier and shorter-limbed and takes sheep. No breeder designed them. No hand selected them. The terrain and the available prey did the selecting. Sexual competition runs alongside survival. Male elk carry antlers that can kill. Male salmon fight for days in spawning rivers. Male stag beetles carry jaws scarred by rivals. The alligator bellows and spins in elaborate display. The males of certain insects battle over females who watch with apparent indifference. The winner reproduces. The loser may not. Among birds, the contest is often quieter, but no less decisive. Male birds of paradise gather in clearings. They move before the females with extraordinary precision. Each feather deployed, each posture held. The females watch and choose. Sir Robert Heron recorded that a pied peacock was preferred by every peahen in his collection. Every other male was passed over. One bird's advantage propagated through the flock. The mechanism is now visible in its full extent. Variation is universal and constant. Reproduction outstrips the world's capacity to hold what is born. Every advantage, however small, tips survival. Every survival tends to leave offspring. Every offspring inherits the tendency that gave its parent an edge. The breeder in the dovecote selects over decades. What operates in nature selects over epochs. The breeder is limited by intention, by lifespan, by the small population of one farm. Nature operates on every individual of every species in every location simultaneously. It never rests. It never has a purpose. It simply preserves what survives and discards what does not. The result, across time enough, is not the pigeon on one man's perch. It is every creature on the planet, shaped by the accumulated weight of every advantage. Every feather, every root, every jaw, every migratory instinct. All of it is the residue of what worked. All of it is the record of a selection no one performed. A starfish does not see the world. It senses light and dark across a scatter of pigment cells. No lens, no chamber, no image. Just the barest awareness that somewhere above, brightness exists. That rudiment is enough to steer by. It is enough to survive. A limpet does more. Its eye is a pinhole, a cup of dark pigment lined with cells. Light enters from one direction only. The animal can track a shadow moving overhead. It cannot form a picture. It does not need one. Between these two creatures and the eye of an eagle, the distance seems absolute. The eagle resolves the movement of a rabbit at half a mile. Its lens shifts focus in fractions of a second. Its retina packs more detail than any human instrument can match. The distance between the starfish and the eagle looks like a chasm. It is not a chasm. It is a staircase, and every step is occupied. The most damaging accusation against the theory of descent is simple. If every living form descended from another through gradual change, the intermediates should be everywhere. The world should be cluttered with half-formed creatures. Fins becoming legs, scales becoming feathers, eyes becoming eyes. They are not visible. The accusation seems to land. But the theory does not require living intermediates. It requires only that they once existed and that they were replaced. A new and better adapted form does not merely spread. It crowds out the form it came from. It crowds out the transitional varieties between them. The parents and the bridges disappear together. This is not a flaw in the argument. This is a consequence of it. The extinction of intermediates is a prediction, not an embarrassment. Wherever a new form succeeds, the older forms that flanked it are gone. What remains are the endpoints, the species that survived. The transitions are in the rock, when the rock preserved them at all. On any given territory, the descendants of a single ancestor diverge. the more differently they come to live, the more of them the land can support. A generalist feeding on one food source competes with itself. A specialist opens a niche that the generalist could not fill. From this pressure comes the branching. Each branch is a lineage that found a way to differ from its siblings. Each difference opened more space. Over generations, the differences deepen. What began as a slight variation in feeding habit becomes a difference in jaw structure. The jaw structure changes the skull. The skull changes the posture. Eventually, the creature is unrecognizable beside its ancestor. The diagram that results is a tree. Green budding twigs at the tips are species alive today. The main branches are the orders and classes that diverged earliest. The fallen wood, the broken stumps, the buried root ends. Those are the extinct. Among the living, a few creatures sit at strange junctions. The platypus connects groups that otherwise have nothing to do with each other. The lungfish lepidosiren lies between the bony fish and the amphibians. They are not relics of confusion. They are the survivors of old divergences. They held their place in a quiet corner while their relatives radiated outward and perished. New and better adapted forms replace and exterminate the parental stock. They also exterminate the transitional varieties. This is why intermediates are absent from the present world. But the geological record is also silent, and that silence must be accounted for. Most of the earth has never been searched for fossils. Metamorphic and granitic rocks outweigh the entire visible ancient record many times over. Sedimentary basins form only on subsiding seafloors. Only when sediment supply matches subsidence does preservation occur. Every elevation strips the record clean. A transitional form living briefly in a small area on a slowly changing continent left almost nothing. It existed for a few 100,000 years. It occupied a narrow habitat. It died in numbers too small to fossilize reliably. It is gone. The record is not a film. It is a handful of frames, separated by long silences. The frames we have show species resembling those above and below them in the strata. The closer the rock layers, the closer the kinship. This is not coincidence. This is descent, read in stone. Return now to the eye. The gradient from pigment cell to eagle spans every intermediate grade. Each grade is still represented in some living creature. Each grade was useful to its possessor at every point. A light-sensitive patch is better than no light-sensitive patch. A pinhole is better than an open cup. A lens that concentrates light is better than a pinhole. A lens with adjustable focus is better than a fixed one. single step requires foresight. No step requires a destination. Each one was simply more useful than the one before it. That margin of usefulness was enough for selection to act on. A different path arrives at a different eye. The squid's eye and the vertebrate eye converge on the same function, but the squid's retina faces the light. The vertebrate retina faces away. The lens structures differ in composition and shape. The nerves originate from different layers of tissue. These two eyes were not inherited from a common ancestor with eyes. They were built independently by different paths toward the same end. Natural selection, working with different materials, arrived at similar solutions. This happens because the problem is the same. Gather light, form an image, transmit information. The solution space is not infinite. Convergence is expected. The wing of the bat did not appear. It accumulated, an arboreal mammal leaping between trees gains from any membrane that slows the fall. A larger membrane is better than a smaller one. A membrane extending further along the limb is better than one confined to the flank. Each incremental extension was useful. Each was heritable. Across enough generations, the glider became the flyer. The fossil record does not show this sequence for the bat. It is gone. But the logic does not require the fossil. The squirrel that glides with a modest membrane still exists. The flying lemur, with its broad skin between limb and tail, still exists. The gradient that produced the bat is visible in creatures that stopped partway along it. Disuse accounts for the other end of the story. In the limestone caves of Kentucky, the fish swim in perpetual dark. Their eyes are vestigial. Some have only the socket. A blind fish in a lit river would die. A blind fish in a cave loses nothing by its blindness. The structures that maintain an eye are not free. When sight provides no advantage, the cost of keeping it begins to matter. Selection stops maintaining what does not pay. The beetles of Madeira tell the same story in miniature. Of the island's beetles, a large fraction cannot fly. The island is windy. Insects that take to the air are swept out to sea. Those that kept to the ground lived. Those that flew were selected against. Generation after generation. The wings that remain are shrunken, fused to the body, useless for flight. They did not disappear by intention. The flying beetles were simply removed. The tree of life accumulates dead wood and green. Most of whatever lived is gone. The branches we can still trace are the lucky survivors of a process that has been running for longer than any number easily holds. What seems miraculous in summary becomes ordinary in slow motion. An eye assembled over 10 million years from a patch of pigment is not a miracle. It is a timetable. The absence of intermediates in the present world is exactly what descent with modification predicts. New forms replace old ones. The bridges are burned as they are crossed. What remains is the tree's outer edge, the living species, the endpoints of every surviving lineage, a starfish sensing brightness in the water above it, a limpet tracking a passing shadow, a fish with a crude lens, a reptile with a more refined one, an eagle resolving a rabbit from the sky. None of these creatures knows what it is part of. Together, they are the staircase. They are the argument made visible, each step still inhabited, each grade still useful. The chasm was never a chasm. It was always a gradient, waiting to be read. Inside the nest, nothing is still. The honeycomb stretches in perfect planes of wax. Each cell joins 6 others at exactly the same angles. No architect drew this. No measurement was taken. The bees do not know geometry. They only know the work. A bumblebee at the other end of the same meadow stores honey differently. It uses old cocoons, irregular and rough. Between these two creatures, the distance in craft is absolute. It is not a mystery, it is a gradient. A young pheasant hatches under a domestic hen. The hen is its mother in every practical sense. But when a dog approaches, the pheasant runs. The hen's alarm cluck triggers a response no hen taught it. The fear is not learned, it is inherited. The pheasant does not run from cats. The hen taught it that cats are safe through daily proximity. So the bird carries 2 kinds of knowledge in one body. One was laid down by 10,000 generations of ancestors. The other was acquired over a few weeks of barnyard life. Both are real. Both govern behavior. They have different origins. A pointing dog freezes above a hidden bird. It has never been trained. It has never hunted. It stands as if turned to stone. One foreleg lifted. The posture is its inheritance, not its education. A retriever carries game back without being asked. A sheepdog circles the flock without instruction. None of these animals knows why. The habit is in the bone, not in the mind. Instincts vary between individuals of the same species. They shade from one form to another across related species. They weaken under domestication and shift under new conditions. None of these facts is incidental. They are the same facts that govern bone and feather. Audubon recorded that nests of the same bird species differ. In the northern states, one construction. In the southern states, another. climate does not explain the variation fully. Something deeper is shifting across generations. This variability is the raw material selection requires. Without variation in instinct, there is nothing to preserve. Without preservation, the behavior cannot accumulate. But variation exists. It always has. The European cuckoo lays a single egg. The egg is anomalously small for a bird of its size. It is placed in the nest of a smaller bird, a reed warbler, a dunnock, a hedge sparrow. The newly hatched cuckoo is blind. It cannot lift its head, but it has a shaped hollow in its back, and it has strength disproportionate to its age. It uses both. Any egg or nestling that touches its back is levered upward, lifted to the rim, and expelled. The foster parents watch. They do not intervene. They continue to feed the single enormous chick that remains. They work harder than they would have worked for their own young. And the cuckoo grows. The American cuckoo builds its own nest. It raises its own young, which hatch in sequence. In Illinois, one was found in the nest of a crested jay. The young of both species were present, nearly fledged. No mistake was possible at that age. 3 Australian cuckoo species lay in the nests of other birds, but none of them has fully perfected the habit. One species sometimes lays 2 or 3 eggs to a single nest. Some eggs are lost. Some hatchlings do not survive. The instinct is not yet complete. Between the American bird that builds its own nest and feeds its own young, and the European bird that dispossesses every foster sibling it encounters, the Australian species occupy the middle distance. They are the transitional forms. They are the argument made visible in living birds. The small egg size is itself an adaptation. A large egg would alarm the host. A chick that hatched slowly might be overtaken by the foster siblings. Speed and smallness give the parasite its margin. Natural selection has shaped the egg as surely as it shaped the back. In the forests of southern England, Formica sanguinea conducts raids. A column of red ants moves toward a neighboring colony. The colony they target belongs to Formica fusca, a smaller black ant. The raid is not about food. It is about pupae. The pupae are carried back. When they hatch, they work. They tend the larvae of their captors. They open and close the nest entrance at dawn and dusk. They seek aphids. They collect material. They do not appear to suffer. They behave as they would have behaved in their own colony. The instincts travel with them. In Switzerland, the red ant receives more assistance from its slaves. In England, less. The panning shot movement of the instinct across geography reveals its history. It has not always been this way. It was once less extreme. On the continent, Formica rufescens carries the dependency further. 30 workers of this species were confined in a chamber. They had their own larvae. They had food. A single slave was kept from them. They did nothing. Several starved. When one slave was introduced, it fed the survivors. It built cells. It organized the larvae. The masters cannot feed themselves. The habit began elsewhere. Ants of many species carry pupae from disturbed nests. Some carry them as food. If those pupae hatch and prove useful, the practice changes in value. What was harvested as a resource becomes retained as a workforce. The selection pressure shifts. The instinct deepens across generations. What began as opportunism becomes dependency. The continental species shows how far the process can travel. The geometry of the hive has been called a mathematical proof. It contains the maximum honey with the minimum wax. A skilled craftsman with instruments would struggle to match it. And yet, no bee has ever studied geometry. The Melipona bee of Mexico builds something simpler. Its honey cells are approximately spherical. They are grouped in irregular masses. Where two cells would overlap, the bee builds a flat wall instead. The cells are not hexagons. They are spheres with plane surfaces at their junctions. This is the intermediate grade, not the rough irregularity of the bumblebee's reused cocoon, not yet the perfect hexagonal columns of the hive bee. Something between, something functional at every point of its own construction. If the Melipona were to build its spheres at slightly more regular intervals, in two parallel layers, at consistent distances from each neighbor, the intersecting planes would become hexagons. The imprecise geometry would resolve into precision. No new instinct would be required, only a more consistent expression of the one already present. An experiment confirmed this. A thick, rectangular sheet of wax, colored red, was placed between two combs. The bees began to excavate from both sides simultaneously. Each side worked toward the other. The excavations became shallow cups, where the cups from opposite sides would have overlapped. The bees left flat partitions. The red wax remained untouched along the plane of intersection. They had located the plane without measuring it. They found it through behavior, not calculation. The gradient from the bumblebee's rough cocoon to this precision is occupied. Each grade is currently in use by some living species. Each grade was useful to the species that possessed it. No step required foresight. No step required a destination. Instinct and structure do not have to change simultaneously. The great tit of England sometimes wedges a yew seed against bark. It hammers the seed with its beak until the kernel is exposed. This is an instinct. The beak is an ordinary beak. If the beak changed slowly, becoming more suited to splitting seeds, and the behavior deepened with it over generations, the bird would eventually resemble the nuthatch. Neither change needs to precede the other. They compound. The structure of mind follows the same rules as the structure of bone. Variation is present in both. Selection acts on both. What survives in one generation tends to appear in the next. The hive, the slave nest, the parasitized clutch. These are not exceptions to the process. They are its clearest demonstrations. The most elaborate behaviors in the animal world dissolve, under patient examination, into increments. Each increment was once the whole of what some ancestor knew. The geometry of the honeycomb is not a miracle. It is a sum. The ant's dependency is not a wonder. It is a history. The cuckoo's blind efficiency is not a design. It is an accumulation, still incomplete in some latitudes, still in progress in others, reading itself forward into forms that do not yet exist. The cliff face is wet. Rain has been working it for centuries. Each layer tells a different season, a different sea. Most of the earth has never been examined for buried life. Metamorphic and granitic rocks outweigh the visible ancient record. That ratio runs approximately 19:1. The weight of what is missing dwarfs what remains. Sedimentary basins form only under specific conditions. The sea floor must be subsiding. Sediment supply must match the rate of that sinking. When those two forces fall out of balance, preservation stops. Every time the land rises, the record is stripped away. Rivers carry the fragments seaward. The evidence dissolves before it can be read. A transitional form on a slowly shifting coastline had almost no chance. It existed for perhaps a few 100,000 years. It occupied a narrow habitat on an unstable margin. It died in numbers too small to fossilize reliably. This is not a failure of the theory. It is a consequence of physics. Ramsay measured the sedimentary formations of Great Britain. The Paleozoic beds alone run to 57,000 feet. The secondary beds add 13,000 more. The tertiary beds contribute another 2,400. In total, nearly 11 miles of compressed time. And that is only what survives. Between every two consecutive formations, enormous gaps exist. The rock formed during those intervals is gone. The creatures that lived during those intervals left nothing. Kroll offered a way to feel the scale. take a strip of paper 83 feet long, stretch it along a wall, mark off 1/10 of an inch at one end. That 1/10 of an inch represents 100 years. The full strip represents 1 million. 100 years of human memory. 1/10 of an inch. The fossil horse tooth found at La Plata was not expected. It lay alongside Megatherium and Toxodon, giants of the South American Pleistocene. The Spanish introduced horses to South America in the 16th century. Those horses went feral and multiplied across the continent within decades. The conditions suited them perfectly. And yet, a native horse had once lived there and vanished. No catastrophe explains it. The horse simply became rarer. Something tipped against it over many generations. The disadvantage was too small to name. It was large enough to matter. Owen noted that size can accelerate extinction. A larger body requires more food. When food becomes marginally scarcer, the large animal suffers first. Insects harassed the elephants of India and Africa long before human settlement. Falconer identified them as a genuine check on elephant populations. Slow, persistent pressure from small organisms contain the largest. This is how species disappear. Not with violence, with arithmetic. The succession of fossil forms tells a quieter story. Fossils from consecutive formations resemble each other more than those from distant ones. The closer the strata, the closer the kinship. Pictet observed this across the Cretaceous and recorded it reluctantly. He did not believe in the transformation of species, but the data would not rearrange itself to suit him. Closely spaced rock layers held closely related organisms. This is not coincidence. This is descent written in compression. When groups of species appear suddenly in the record, the appearance is deceptive. A species evolving slowly in one region may spread rapidly once it gains some advantage. Its arrival in the European record looks sudden. Its long preparation happened elsewhere. Barnacles make this plain. Their shells are hard, abundant, and preserve well. A careful study of the tertiary record found none below a certain layer. Then a complete specimen arrived from the Belgian Cretaceous. The group had not appeared suddenly. It had simply not been found earlier. Woodward later found another barnacle genus in the Upper Cretaceous. The sudden appearance dissolved into ordinary history. Absence of evidence is not evidence of absence. The negative testimony of an empty layer is nearly worthless. The Cambrian problem is the hardest silence in the record. Below the Cambrian, the evidence thins to almost nothing. Yet the Cambrian itself opens with fully formed trilobites and mollusks. These already display complex eyes, articulated bodies, and specialized limbs. They must have ancestors. Those ancestors require time. Long before the Cambrian, the world must have been full of life. Barrande found a primitive fauna lying below the known Silurian. Hicks found trilobites in the Lower Cambrian in South Wales. Logan measured the Canadian Precambrian formations. Their thickness may exceed the entire Paleozoic record above them. Eozoon was found in the Laurentian Rock of Canada. It extended the record of life into a time geologists had called lifeless. The formations before the Cambrian may lie beneath present oceans. They may have been crushed and heated into metamorphic rock beyond recognition. The absence of Precambrian fossils is a genuine problem, but it is a problem of preservation, not of history. Lyle spent his career documenting the slowness of geological change. He had also spent most of that career defending the fixity of species. By the later editions of his work, he had reversed his position entirely. The man who understood rock better than almost anyone read the same conclusion from it. Not because every transition was present, but because the patterns of similarity, succession and absence all pointed one way. The geological record is not a film. It is a handful of frames separated by long silences. Where variation appears across layers, it appears gradually. Where species vanish, they thin before they disappear. The record is not complete. It never will be. But the pages that survive are not telling the story they were supposed to deny. They are telling the only story the evidence supports. The cliff is still wet. The rain is still working. Another layer is being written. It will not be readable for a very long time. Two archipelagos rise from the same ocean. Both are volcanic. Both sit under the same latitude of sun. Both receive the same rain, the same wind, the same salt air. But their inhabitants are not the same. The Galapagos Islands lie 600 miles off South America. Their birds and plants bear the unmistakable mark of that continent. The Cape Verde Islands lie off the coast of Africa. Their creatures resemble Africa, not America. The conditions of life on these two island groups are nearly identical. The inhabitants are entirely different. Climate did not draw this map. Something else did. A naturalist moving south along the American continent hears familiar voices. The birds change. The species shift. But each new form resembles the one before it. A rhea on the plains near the Strait of Magellan gives way to another rhea to the north. Not an ostrich, not an emu. Another rhea, a different species. unmistakably American. On the pampas of La Plata live the agouti and the vizcacha. Both are rodents. Both live as hares live in Europe, but they are not hares. They carry the structure of South American animals. Climb into the Cordillera and find mountain vizcachas. Turn to the rivers and find the coipu and the capybara. Everything is recognizably American, across climate and elevation and habitat alike. This is not a coincidence of conditions. This is the signature of inheritance. No barrier shapes the living world more powerfully than open ocean. Frogs are absent from oceanic islands that suit them perfectly. Introduced frogs thrive on Madeira, on the Azores, on Mauritius. They multiply rapidly once placed there. Yet no frog has ever crossed salt water on its own. Eggs and adults of amphibians die almost immediately in seawater. No current carries them. No wind lifts them. The ocean is not merely inconvenient for them. It is a wall. Terrestrial mammals follow the same pattern. No terrestrial mammal lives on any true oceanic island more than 300 miles from land. Not one, unless carried there by human hands. Bats are different. Bats fly. Bats appear on nearly every island, however remote. New Zealand has 2 bat species found nowhere else on Earth. The Viti Archipelago, the Mariana Islands, Mauritius, all have their own bat species. The question answers itself. Only what can cross the water reaches the island. Their absence is not a gap in creation. It is a map of the sea. Seeds travel farther than animals. Experiments showed that seeds of many plants survive weeks in seawater. Out of 87 species tested, 64 germinated after 28 days. Some survived 87 days of immersion. Atlantic currents average 33 nautical miles per day. A seed surviving 87 days could travel more than 2,000 miles. Seeds also travel by other means. Dead birds float at sea with undigested seeds still in their stomachs. Live birds carry mud on their feet. A single lump of dried clay, weighing 6.5 ounces, yielded 82 plants. Locusts drift in swarms across open ocean, carrying seeds in their droppings. Over tens of thousands of years, these occasional passages accumulate. One seed in 100 takes hold, but time is immense. And the result is an island flora that traces clearly back to the nearest source. On the Galapagos, each island carries its own variant. The mockingbirds differ from island to island. The tortoises differ so clearly that their home island can be read from the shell alone. The finches differ in beak, seed crackers here insect probers there, cactus feeders elsewhere. Each island received its colonists from South America. Each island then shaped those colonists independently. The competitors were different on each island. The food sources were different. Generation by generation, the pressures diverged. What began as one immigrant population became many distinct species. The distance between islands is only miles, but deep channels separate them, and currents run strong. Each island became its own selective world. The mountaintops of the world tell another version of the same story. The same alpine plants grow on the peaks of the Alps and the Pyrenees. They grow on the mountains of Lapland and the White Mountains of New Hampshire. They grow on the high ridges of the Himalayas. These summits are separated by thousands of miles of warm lowland. No alpine plant migrates through tropical valleys. Yet the same species sit on these separated cold peaks. The explanation requires ice. During a past epoch, the climate cooled severely across the northern hemisphere. Arctic flora spread southward across the plains of Europe and North America. When warmth returned, the Arctic forms retreated toward the poles. Where mountains stood, the plants climbed. They became stranded at altitude as the lowlands warmed beyond their tolerance. The same migration, the same species, the same retreat, repeated across every mountain range. The summits of Europe, Asia, and America were stocked from one connected source, now separated by continents, but recognizably alike. Inside every wing, every flipper, every foreleg, every human hand, the bones are the same. The wing of a bat carries the same bones as the arm of a man. The flipper of a porpoise carries the same bones as the foreleg of a horse. The arrangement never changes. What changes is proportion. What changes is function. Embryos reveal this unity most clearly. The embryo of a mammal, a bird, and a reptile are nearly indistinguishable in early stages. Gill arches form in the throat of every vertebrate embryo. In fish, they become gills. In land animals, they are modified into other structures. But they appear first in the same form, in the same position, in every lineage. A fetal whale carries the rudiments of teeth it will never use. They appear in early development, then are absorbed. The adult whale has no teeth, but the embryo insists on building them, because inheritance has not yet erased what was once necessary. The boa constrictor carries a vestigial pelvis, no legs attached to it, no function demands it. It is there because the boa's ancestor walked. These residuals are not ornaments. They are historical documents written in bone. The pattern is now complete. The Galapagos resemble South America because they were settled from South America. The Cape Verde Islands resemble Africa for the same reason. The mountaintop plants of 3 continents are the same because one ice age connected them. The bones inside a wing and a flipper are identical because they were never redesigned. The fetal whale builds teeth because its lineage built teeth long before the sea claimed it. Every fact that seemed separate now speaks the same sentence. The sentence is, these things share ancestors. The map of life was never arranged by independent acts of creation. It was written by dispersal, by isolation, by time, by descent. Each island was reshaped by its conditions. Each embryo recapitulates a history no living animal can remember. This is not a collection of resemblances. It is a single fact, read from every direction at once. The world, examined in this light, becomes the record of one long connected process, a process that left nothing untouched and is still continuing. The objections are still standing. They have not been dissolved. They have been weighed and found lighter than what stands against them. Hybrid sterility has long been treated as a boundary. 2 species cross and the offspring cannot reproduce. This has been called a natural marker, a sign that species are fixed, that kinds do not mix. But domestic animals cross freely. The pig breeds in any cage. The dog multiplies under the most varied conditions. The elephant refuses. The fox refuses. Not because they differ in kind, because they were built for constancy and then disrupted. The sterility of hybrids follows from this. 2 organisms long adapted to stable conditions are forced together. Their reproductive systems were tuned to separate worlds. The disruption of that tuning produces the sterility. It is not a divine marker. It is a collision of 2 long histories. The evidence lies in the direction of the cross. Use species A as father and species B as mother. Then reverse it. The results differ. Sometimes one direction yields seeds, the other yields none. No fixed boundary behaves this way. A consequence of physiology does. Dimorphic plants confirm this from a different angle. When the wrong form fertilizes another of the same species, the seeds are few and the offspring less fertile. The sterility tracks the fit between reproductive systems, not the distance between kinds. The argument now gathers what has been laid across the previous reaches. Variation is present in every population. No 2 individuals in any species are identical. This is not a curiosity. It is the precondition of everything. Reproduction outpaces the world's capacity to hold what is born. the annual plant, the elephant, the fulmar, all press against a ceiling. The ceiling is not imposed from outside. It is the fact of a finite world pressing back. Within that pressure, small advantages compound. The wolf that runs fastest leaves more descendants. Those descendants run faster than average. Across hundreds of generations, the change becomes visible. No individual changes. The population shifts. The shift is heritable. It continues as long as the advantage persists. Extinction follows from this directly. New forms replace old ones. The parental stock disappears alongside the transitional varieties. The pace is slow by any human measure. On the scale of the earth, it is continuous and uninterrupted. The resulting pattern matches what is found in the living world. Classification groups creatures into nested hierarchies. This is exactly what common descent produces. Creatures resemble their nearest relatives most. The embryos of a mammal, a bird, and a reptile look alike in early stages. They follow the same inherited program before it diverges. Vestigial structures testify to vanished histories. The fetal calf carries teeth in its upper jaw. They will never cut through the gum. But the ancestor of the calf had teeth, and the inheritance persists. The rudiment is a document. It records what selection has not yet erased. What the theory makes possible is a change in what questions are worth asking. Classification will become genealogical, not a catalogue of resemblances, but a record of branching. The tools will be found in embryos, in rudiments, in the bones of the hand. The human hand, the bat's wing, the porpoise's flipper, the horse's foreleg. One structure, modified by selection, inherited from one ancestor. Not analogy, not coincidence. History. The rudimentary pelvis of the boa constrictor will be read as a record. The boa's ancestor walked. The pelvis remains. The organ is silent now. But silence, read carefully, speaks. Species now treated as anomalous will be recognized differently. The platypus, the lungfish Lepidosiren, not errors of creation. They are survivors of lineages whose relatives are long extinct. They are windows into forms the rest of the tree has left behind. They are, in the language that will follow this theory, living fossils. The breeding of new varieties under domestication will be treated as experiment. Every pigeon breed, every strain of wheat, every variety of cattle is a small controlled demonstration of what accumulation accomplishes. The study of these will carry more weight than one more unnamed species. Natural history will attend to causes, not only to forms. The laws governing variation will be investigated directly. Correlation of growth, compensation, use and disuse. These are not decorative topics. They are the mechanisms. The long questions remain open. The origin of life itself is not answered here. The first variation, the first inheritance, these lie beyond what has been traced. The imperfection of complex organs in some lineages is not fully explained. What existed before constrains what can be built next. No structure is ever redesigned from scratch. Selection cannot plan ahead. It preserves only what is better than what existed before. The path through which a structure was built is embedded in the structure itself. A bank of tangled growth stands at the edge of still water. Plants of many kinds press against one another. Birds move through the upper branches. Insects hang in the air above the stems. Worms work through the damp soil below. All of it arrived here through the laws that operate everywhere. Growth and reproduction. Inheritance of variation. Pressure from competitors. Predators. Parasites. And drought. Small advantages preserved across generations too many to number. The complexity visible in this one scene is not the work of many hands. It is the work of one process, running on every individual in every generation since before the Cambrian strata were laid. Each creature here is the latest result of an unbroken line. The line extends back past the first known fossils. It extends forward into forms that do not yet exist. From so simple a beginning, a variation, an advantage, a survival, the forms that now fill this bank have been and are still being produced. The record of what came before is not complete. It will never be complete. But what it says, in the strata and the embryos and the bones, in the vestigial teeth and the rudimentary pelvis and the wingless beetles, points in one direction, and that direction holds. The script was based on the book, On the Origin of Species, authored by Charles Darwin, and first published in 1859. Thank you for watching. Until the next journey begins.